All right. Thank you very much. Recording is started. It is January 20th, 2023, 8:18 p.m. I'm Raj Dixit, Vice President of SVAS. Tonight's lecture is going to be about the winter skies. But before we get started on that, I wanted to talk about Comet C22E3, or Comet ZTF. This is a photo of it taken by Michael Yeager and published in Sky and Telescope. This comet is rapidly approaching. It'll be at perigee, or closest approach to Earth, on February 1st, at which time it will be 26 million miles from us. Current visual magnitude is between 6.5 and 7, so just outside naked eye visibility, but fairly easy in 10 by 50 binoculars, especially if you have a good dark clear sky. This is coming to us straight from the Oort cloud and hasn't been here in at least 50,000 years. And it may never come back because they're still working on its trajectory. It may return to the Oort cloud and loop back in untold millennia from now, or it may take a hyperbolic path and go outside of the solar system. Time will tell if it does become bright enough to be seen with the naked eye. If it does, around February 1st, it'll probably be between 5.5 and 6. So that's right at the edge of naked eye visibility. You'd have to be have very good eyes and very dark skies to see it with your own eyes. Now it's named Comet ZTF for the Zwicky Transient Facility, which is based out of Palomar Observatory in San Diego. Fritz Zwicky was a very preeminent astronomer in the early 20th century, and that facility is dedicated to looking for comets and asteroids. And every 2 nights, it has a wide field CCD camera attached to the 48-inch Schmidt-Cassegrain telescope down there. Actually, it's just a pure Schmidt camera, and it scans the northern sky in search of anything that blinks or moves. It's found 6,600 supernovas to date. It's found many near-Earth asteroids, numerous comets. This particular comet was discovered on March 2nd, 2022, and it was logged as a possible asteroid. But the next night, a Japanese amateur, Hirohisa Sato, was taking photographs of it and discovered that it had a coma. So they realized, and thanks to him, it was realized this is not an asteroid, this is indeed a comet. At the time, it was only 17th magnitude, and it was about as far away from us as Jupiter is, about 5 AUs from Earth. So how do we find it? Well, here is a fairly user-friendly chart. Today being the 20th, it's going to be, I may go out and look for it tonight, actually, since take advantage of the clear skies. It is just off the handle of the Big Dipper. Suppose if you wanted to make a large triangle, you'd use Kochab, which is in the bowl of the Little Dipper, or Ursa Minor. The last handle star of the Big Dipper, Alcade, and then maybe go about half, almost in the middle and straight down. I guess the nearest bright star looks to be Eta Draconis. Technically, it's actually in the constellation. It's not in Draco. I think technically it's in the boundary of Boötes. But Boötes isn't fully up. That's the head of the shepherd, the herdsman, and this is about the thorax of the dragon. It will get progressively better by the time we get to February 1st. Its closest approach should be fairly close to Polaris, and it might form an equilateral triangle with Polaris and M81, M82. So the way to find it that way would be, if you look at these 2 stars in the bowl of the Dipper, and you connect them in a line and follow it, it takes you out to M81, 82. If you keep going, you should be in the vicinity of the comet. I have put both finder charts, links to them, in the chat. So that's Comet ZTF E3, and ZTF again stands for the Discovering Facility, the Zwicky Transit Facility. C22E3, the explanation is as follows. The C means it's not a periodic comet. It's not periodic. It does not appear on any sort of regular schedule. Pamela, Halley's Comet is a comet 1P, meaning the first periodic comet to be discovered. C 2022, because that's the year it was found. E3 tells you the time of the year it was discovered, because A means the first half of January, B means the second half of January, etc., and 3 means that there were 3 other comets discovered during time period E. So comet C2022, E3, or comet ZTF. So that's all about that. Okay. I will now begin the presentation. Give me a minute here. Okay. Pulling it up, share screen. There we go. All right, here we are. So this is an exploration of the winter night skies. Is my toolbar visible, or is it only the PowerPoint that's visible?
PowerPoint.
Just PowerPoint.
Okay, good. Yeah. Glad to hear that. So, winter is coming, but you don't have to be a Game of Thrones fan to enjoy this presentation. We're going to be talking about what you can see, the deep space objects of the winter skies. So, there we go. This is what the night sky looks like over Sacramento at around midnight. You'll see some stars. The brightest stars of winter are in the Winter Hexagon, starting at Capella and Auriga, Aldebaran and Taurus, Rigel and Orion, Sirius and Canis Major, Procyon and Canis Minor, and then Pollux and Gemini. What we'll do is we'll proceed around the hexagon and consider those constellations with maybe a few detours, and talk about the deep space objects visible inside them. And if you have any questions, put them in the chat room if you don't mind, that I can get to them at the end of the presentation. I think that'll make it move more smoothly. So first up is Auriga the Charioteer. Okay. And again, this is the Winter Hexagon. At the top of it is the constellation Auriga the Charioteer and the bright star Capella. There is a map of the constellation. Capella is Alpha Aurigae, and there are 3 notable Messier objects, open clusters within the bounds of Auriga. Capella looks like a single bright yellow star to the naked eye, but it's actually a quadruple star system organized in 2 binary pairs. However, they are so close together that only professional telescopes and observatories can split them. We're not going to be able to do it in our amateur instruments. The primary bright star you see, Capella, it's 2 bright yellow giants in a binary system, both of which are about 2.5 times as massive as our own sun. So, as we work our way through the constellation of Auriga, and that's how Auriga looks in the sky. You can see Capella there, and how anyone thought this vaguely hexagonal shape was a charioteer is beyond me, but it is Auriga the Charioteer. That is open cluster Messier 36 or M36, 4,100 light years away, about 25 billion light years old, 14 light years across, and contains about 60 stars. Open clusters, as you hopefully know, are young stars. These are stars that were all born out of the same common cloud of gas and dust. And even though the gas and dust has dissipated, a core group of young stars, siblings, are all that's left. Now, with time and tide and gravitational effects, they will disperse to the arms of the Milky Way. It's believed that our own sun was once inside an open cluster. But since the sun is about 6 billion years old, that open cluster has long since been scattered and dispersed randomly throughout our local vicinity. There's Messier 37, which is the brightest of the open clusters in the constellation. There are over 500 stars inside. It's 4,500 light years away, and it's somewhere around 400 million years old, plus or minus 50 million years old, given according to best estimates. Next up is Messier 38, also known as the Starfish Open Cluster, 4,200 light years away, about 220 million years old. Again, it must be emphasized, these are young stars, much younger than our own sun, much younger than Earth. Usually think of stars as being much more ancient than our own humble planet Earth, but these stars are the exception. They're bright, blue, and hot, and young. This is about 26 light years across. There are 100 confirmed members, and the brightest star in this cluster has been calculated to be 900 times brighter than our own sun. Our next stop is the constellation of Taurus, the Bull. The brightest star is the red giant Aldebaran, which is 65 light years away and 518 times brighter than the sun. It's also 44 times the sun's diameter. So it puts the giant in red giant. And a fun fact is that Aldebaran comes from the Arabic for Aldabaran, the follower, because what rises first as you watch the sky are the Pleiades and Messier 45. And as the Pleiades get higher and higher after they rise, soon following is Aldebaran. So Arabic astronomers call it Aldabaran, the follower of the Pleiades. That's how Taurus looks in the sky. It's you can see the Pleiades up there. They're technically inside the constellation boundary. Of course, cameras make things look brighter than they appear to the naked eye, but Taurus does look like at least the head of a bull. You can definitely see the horns there. And there's Aldebaran. So those are, of course, the most famous object in Taurus, and probably the most famous open cluster of all time, the Pleiades, Messier 45. This was taken by the 48-inch Samuel Oisin Schmidt telescope at Palomar. This is 444 light years from us, about 113 million years old. There are an estimated 500 total stars and a total luminosity of about 4,800 times that of our own sun. Now, and you can still see reflection of leftover dust from the formation of this cluster. You browse the cluster at low power, which is the best way to see it, because if you zoom in on it too highly, you don't get a feel for the entire structure. To go through it at low to medium power, you get an idea of how big it is, how much space it takes in the sky, and of how many stars are inside of it. So this is a wide field view, naming the individual stars. The Pleiades were 7 sisters of Greek mythology, and the 7 sisters motif has been repeated in many cultures. I know in India, and in the Hindu mythology, this cluster is referred to as the 7 sisters, the Saptarshis. And in Japan, it's also known as the group of 7, the Subaru, okay, which explains why the Subaru logo. Next time you see a Subaru automobile, look at the Subaru logo, and you'll see this cluster. Subaru means united in Japanese. So here's the closest open cluster to Earth. It's called the Hyades, and it's basically the face of the bull. It's a large extended open cluster about 150 light years away and about 17 light years across, and it's the closest open cluster to the planet Earth. It's better as a binocular object. Trying to look at the Hyades in a telescope, unless you have a very low power rich field telescope, is more or less a lost cause. But in binoculars or a low power wide field, it's quite striking in appearance. That is Messier number 1, the Crab Nebula, the famous object. It's a supernova remnant. It's about 6,500 light years away and 11 light years in diameter. It's expanding at about 3 million miles an hour and getting dimmer for that reason. In fact, it's theorized that Messier might not find it today. It was probably considerably brighter in the 18th century when he was looking. The original star that gave rise to this before it went supernova was estimated at 10 solar masses. And this star was first seen in China in the year 1054. And based upon translation of their records, it translates to our calendar. It was first seen on July the 4th. And it was bright enough to be seen in daytime for quite some time. So this is of course a Hubble image of the Crab Nebula. Oh, yeah. That's how the Crab Nebula looks inside, say, a 10-inch Dobsonian at low to mid power. It's a fairly uninteresting blob, but it is important to see as it is the first of the 110 objects in the Messier catalog. Wow. This is known as the Crystal Ball Nebula. It's NGC 1514. It's a planetary nebula, meaning it's a star roughly the size of the sun that outlived basically burned up most of its usable fuel, and then blew off its outer shell and formed a planetary nebula. And now all that remains is the white dwarf at the center. It's about 2,200 light years away. Moving on, we get to Orion, the Hunter. It's the most famous winter constellation, and it might be the most famous constellation, period. It's a huge constellation. It takes up a great deal of space in the sky, and it's instantly recognizable. That's how it looks in the sky. Now, of course, the camera makes it look brighter than it is, but still, if you're out in even in city lights, unless you're in the middle of downtown Sacramento, but even from suburban city lights, the shape of Orion is usually pretty easy to spot because it's so distinguishable. And you have Betelgeuse, you have Rigel, you have the Great Orion Nebula as the sword, you have the three belt stars, Alnitak, Alnilam, and Mintaka, the horse head being right below Alnitak. And there's the most famous object in the most famous constellation, the Great Orion Nebula, Messier 42 and 43, also known as Demaran's Nebula, because it was unclear, at least to Messier, whether or not this was one object or two separate objects separated by dust. So that's why it has two Messier numbers. This is a Hubble image. This nebula is about 1,350 light years from us, 24 light years across, which is 20,000 times the size of our solar system. It has an estimated 2,800 stars, at least. That's a Hubble close-up of the trapezium, the brightest stars at the center of the nebula, which are visible even in binoculars and can be resolved in a good telescope with good seeing. That's a wide field image taken by an amateur, taken with an Orion 80 millimeter ED glass refractor. So it gives you M42 and it gives you NGC 1973, 1975, and 1977, collectively known as the Running Man Nebula. Because if you look at the dark shadow inside, you almost see a little homunculus, a little running man. Another famous Messier object in Orion is, and that's how the Orion Nebula looks in a telescope. You might get a hint of green with large aperture and very clear skies. Normally, it's basically gray. This is Messier 78, a reflection nebula at the top left of Orion, between Betelgeuse and the belt. And this is what Hubble sees. This is a reflection nebula. These gases are glowing, not because stars are heating them up to a point where they themselves ignite and glow, but there are two stars that are causing reflections of the surrounding gas and dust. So And that's how it looks in a Dobsonian, say it's about a 8 to 10 inch Dobsonian at about 100x magnification. And this is about 1600 light years away. Yeah, it's Hubble gives you unrealistic expectations, as it does with a lot of things, but this is especially true for Messier 78.
Wow.
It's just a wisp. Now, this photo was taken by a very skilled astrophotographer. It contains the emission nebula NGC 2024, or the Flame Nebula, which I'm circling, also known as the Tank Track Nebula. And there's a fainter emission nebula, IC 434, with the red being burning hydrogen and burning sulfur. And there's a lot of cold gas and dust. This is an active region of star formation and star birth. And when you have that, you also have, in addition to the emission nebulas, the gases are glowing because the stars nearby and stars being born inside are so hot that they cause the gas and dust to ignite and give off their own light. But where you have that, you also have clumps of cold gas and cold dust, which are the globules, which when they compress together are the stuff of which stars are made. And here you see the most famous dark nebula of them all, the Horsehead Nebula, Barnard 33. And that's how the Flame Nebula looks in a mid-size 8 to 12 inch Dobsonian. Alnitak is there, which can make it hard to see. It helps to have a narrowband filter. It's not strictly necessary, but it does help. And there is the Horsehead Nebula. As you can see, you don't really see a horse head. You see a faint background of IC 434, and you see a notch or bite that appears to be missing from it. It really helps to have a hydrogen beta filter attached to your eyepiece to see this. You don't need that much mag. It helps to have aperture and good skies and low mag, actually lower to medium mag. High mag makes it too dim, in my experience. The first time I ever saw the Horsehead was through, was at Black Butte through a 32-inch Dobsonian belonging to a friend of mine, and it was hard to see. But a couple winters ago, I did see it through my own 16-inch Dob at HGO, and it actually looked remarkably like this. And it was faint, but it was clear. And I think having a good clear winter sky up there at the time is what made it possible. So this is about 1,400 light years away, and the Horsehead itself is about 7 light years in diameter. Here's a little detour. If you go right below Orion, you see the small constellation of Lepus the Hare. Now, Orion was hunting the hare, according to Greek myth. And this is globular cluster Messier 79, which is one of the very, very few globulars you ever see in winter. Most globular clusters are summer and fall objects. This is a very unusual location, about 60,000 light years from the galactic center. It's in the hemisphere opposite the galactic center. And it is believed that this cluster is an immigrant from the Canis Major dwarf galaxy, which is currently experiencing a close counter with the Milky Way and losing. And there are 3 other globular clusters that they're believed to have the same origin. The Milky Way is currently absorbing the Canis Major dwarf galaxy and is pulling out a huge tidal tail of material. There are about 150,000 stars in this glob. Most of them are red giants, but there are a lot of blue stragglers, old stars that appear younger and bluer because they're interacting and colliding with other stars in the cluster because the core is so dense. This is estimated to be 11.7 billion years old. It's 41,000 light years away from Earth, and it's receding from us at about 200 kilometers per second. The next constellation, as we work our way through the hexagon, is the big dog, literally Canis Major. And it's one of Orion's 2 hunting hounds. Sirius is supposed to be his eye, fixed on Lepus the Hare, which was Orion the hunter's target. And there you go. There's a map of the constellation. Sirius is the dog star or the Nile star. It's designated Alpha Canis Majoris. And it's the brightest star, not just in that constellation, it's the brightest star in the night sky as seen from Earth in either hemisphere. Its name comes from the Greek Sirios, meaning glowing or scorching. Its apparent magnitude visually is minus 1.46, so twice as bright as Canopus, which is the second brightest star. It's a binary star with the main star is an A0 type star, or A1, which is a blue, a hot, large, young blue
Let me know
star.
when it's like 5-2, okay?
Okay.
Yeah.
And
I was watching.
all right. And there is a faint companion, Sirius B. It's a very, very, very challenging object to see because it's a faint white dwarf. The distance varies between 8 and 32 astronomical units. They orbit every 50 years. Yeah, you can see in this Hubble image, Sirius A is overwhelmingly bright. Sirius B is tiny. I was able to see it in my 120 millimeter apochromatic refractor. The trick is to get Sirius in your eyepiece, let it drift out, and then just right after it drifts out, you hopefully can see the glare will fade. And you'll get a glimpse of the companion right before it also drifts out of the field of view. Now, Sirius is popularly known as the dog star because it's in the big dog, and the ancient Egyptians had great interest in this star because it's a winter star, but toward the end of summer, they would wait till the wee hours of the morning. And because at the very end of summer, if you stay up late long enough, right before sunrise, you will see Sirius rise. And on the first time you could see Sirius rise, they would know, the Egyptians knew, that the Nile flood, the annual Nile flood, was very imminent, would probably begin in about a week. So that is believed to actually be the origin of the term the dog days of summer, because the end of summer, you're looking for the dog star. And Sirius is only 8.6 light years away. It's very close, and it's getting closer. So it's going to get brighter for the next 60,000 years. And then after that, it'll start dimming. But it's believed that it will be the brightest star as seen from Earth for the next 210,000 years. So this is Open Cluster Messier 41, which is located right close to Sirius. It's a gorgeous open cluster, easy in binoculars and very good in a small telescope. It's got 100 members, roughly 2,300 light years away, 25 light years in diameter, 190 million years old. And the distinctive red star, basically at the center of the cluster, is about 700 times as bright as the sun. And here's a cool object. It's popularly known as Thor's helmet because it looks like the helmet worn by the famous Norse mythological figure. It's about 30 light years across. The helmet's basically an interstellar bubble. There's a bright, massive star at the center called a Wolf-Rayet star, an extremely hot, giant blue star, which has a very brief lifetime because it's going to go supernova any minute. Stars that big and bright don't live long. Now, the official name is the much more boring NGC 2359, but it's located 15,000 light years away from us. And this image was made using a combination of broadband and narrowband filters. And the preeminent bluish green color comes from oxygen 3, burning oxygen. And that's NGC 2360, a very nice open cluster discovered in February of 1783 by Caroline Herschel, the sister of the great William Herschel, the most famous visual observer of all time. It's called Caroline's cluster because William named it in her honor. It's 3,700 light years away and about 15 light years across. Here's another open cluster in Canis Major, NGC 2362. It's about 5,100 light years away, 5 million years old, estimated, about 60 members, and estimated to be about 500 solar masses in total. Then you have this lovely, lovely double star in orange and blue. And if it's orange and blue, if it reminds you of something, it's actually nicknamed the Winter Albireo. And it was discovered by John Herschel, the son of William Herschel. And again, we'll take a slight detour to go to the constellation of Monoceros, the unicorn. This lovely object is famous. It's known as the Rosette Nebula. NGC 2237 through 39, those numbers describe the nebula itself, because especially when they were cataloging it back in the 19th century, they thought they might be seeing 3 separate nebula. They weren't sure it was one entire object. And the open cluster at the center goes by NGC 2244 and 2246. This is a Hubble image. This is 5,200 light years from Earth, 130 light years across. And the total weight of everything here is estimated to be about 10,000 solar masses. That's how it looks in a mid-sized Dobsonian. And it does help to have a broadband or ultra-high contrast filter. And this is about medium mag, about 100x. That's NGC 2506, which is a nice little open cluster in Monoceros. It's about 11,300 light years away and about 2 billion years old, which is remarkably old to still be an open cluster. Continuing on, the next part of the hexagon is Procyon, which is the bright star of Canis Minor, the little dog. And Procyon literally means before the dog. It's about 11.5 light years away. It's 7 times brighter than the sun, about 1.5 solar masses. It's a binary star, but it's extremely difficult to split. Its companion is 15,000 times fainter than the primary. So I don't think I've ever been able to split it or see the partner. And there it is through a far greater telescope than any of us will ever have. I believe that's a Hubble image. And the last constellation in our journey is Gemini, the famous twins. Now, in Greek myth, Castor and Pollux were twin brothers, and they were inseparable. They were the best of friends. But by the machinations of the Greek gods, Pollux was immortal, Castor was not. So when they were separated inevitably by Castor's death, they were eventually given their wish to be reunited eternally in the heavens. They always set in the west together, and according to myth, it's because there's proof of their inseparability. Now, strangely, Castor is designated Alpha Geminorum, the brightest star, even though Pollux, Beta, Pollux is brighter visually. You can see that Pollux is brighter, yet for whatever reason, Castor was designated Alpha. The origin of this error is unknown. Now, Castor, there you go. You can see how they look in the sky. It's the completion of the hexagon from our perspective. And then Castor, Alpha Geminorum, or Struve 1110, is a 6-star system consisting of 3 binaries. Now, in amateur scopes, only 3 of those 6 stars are visible. And that requires a very good scope and very good sky. Normally, only 2 stars of the binary are generally visible. This Castor system is 51 light years away, and the 2 easily visible stars are 5 and 25 times brighter than the sun, respectively. This is Messier 35, a very nice bright open cluster in Gemini with 500 stars, 2,800 light years away, 24 light years in diameter, and it's approaching us. Most things in the universe are flying away from us as fast as they can, but Messier 35 is actually approaching us at 11,000 miles an hour. And this is the image that I was using in the background. The other open cluster here at the lower right is NGC 2158. It's very close visually, or apparently, to M35, And if you have a good wide field scope, you can get them both in the same field of view. 2158 is 11,000 light years away, and it's one of those older open clusters. It's 2 billion years old, which is quite old for an open cluster. That's open cluster 2266, lying about 10,000 light years away. And it's about a billion years old, which is old for an open cluster. And it's so old that even though open clusters are predominantly young stars, some of them have already started to go red giant, meaning that they're reaching the end of their lives. That's NGC 2420, another open cluster in Gemini. It's 8,600 light years away, 30 light years in diameter, and has about 1,000 members. Every one of these objects, by the way, that I've mentioned is visible in an amateur scope. I've seen them all personally in my various telescopes. That's why I drew particular attention to these particular objects, in case you're wondering how I picked the objects for each constellation. Obviously, Messier's and very famous ones like that will take priority, but some of the more miscellaneous NGC clusters are ones that I found intriguing and ones that I have seen. And last but never least is NGC 2392, formerly known as the Eskimo Nebula or the Clown Face Nebula. It's a planetary nebula that's 6,500 light years away, and it's only 10,000 years old. Now, this is a Hubble image. Regrettably, it does not look like that in any telescope that any of us would have, but it's still a worthwhile object because that is a fair depiction of it in a good Dobsonian under good conditions, and it can take high mag if the skies are steady. All right, ladies and gentlemen, that was our tour of the winter skies. Now you have some idea of where to focus your attention, the core of the winter skies. It's not only the winter hexagon, but the winter hexagon would be basically the torso or the core of what you're looking at during the winter sky.